Hello friends, welcome back to the bench. Today we have an EVGA GeForce GTX 650 Ti boost. This is mine, and until last night it was in my rig, and last night for some reason it decided to die on me. This is basically what happened. The computer or the rig was working under regular load, nothing too extensive, and suddenly it froze. The sound buffer went into loop, so that you probably know what I'm talking about. Loud sound from the speakers when when you short the CPU or there's some short somewhere. It sometimes happens, or you can trigger that, or if you short the crystal, you can simulate that. Anyways, I turned it off. I turned it back on. It wouldn't turn on. The red light was blinking instead of turning into green. I removed the GPU, started the rig with on the internal GPU, and it started. Then I replaced it with some crappy GeForce GPU that I have lying around, and it works fine. It's working right now. So, using the method of elimination, I think that the GPU has short. So I'm gonna just run a quick diagnosis. Unfortunately, I never build my rig for testing GPUs because of this board, and I never actually replaced it because I figured I started working on the ECMs and PSUs, and I figured I'm probably never gonna work on the GPU. Besides, nowadays it's not as popular as it used to be when the Bitcoin mining and other crypto mining was a thing, or thing that was actually profitable. So I'm not going to be able to test the memory, but I don't think that the memory is at fault here, because if that was the case, the computer would start and you would see maybe some artifacts, some garbage on the screen, or maybe the screen would not turn on or something like that. This one just wouldn't, the computer just wouldn't start. So I suspect that there is a short or perhaps an open line, because once you connect the GPU, the external GPU, then it tries to use it. So even so if it doesn't work, then the computer doesn't work. If you remove it, you run on the internal card, then you can turn it on the internal card. And the same thing if you have GPU connected and you connect the monitor to the built-in card, it's also not gonna, it's actually gonna show you at least this board is gonna show you the warning that you have GPU connected, but you connected monitor to the internal card and it won't start. All right, let's see what we got. Okay, so here's our patient. As you can see, it accumulated a lot of dust, to be expected. Normally I would do a visual inspection first under the microscope, but since I'm the owner of this device and it worked in my rig for a long time, I know exactly what it has been exposed to. So I know I'm not going to find any liquid damage, I'm not going to find any physical damage, because it was in my computer, right? Now all we're gonna need is just a multimeter for now, and if that doesn't show anything, then we're gonna use the tester to test the data lines, because that's a little harder with actually it's not, it's just a little hassle to do it with the multimeter. It's better to use that. I'm gonna set the multimeter in a diode mode, and since I suspect a short, all the power that comes to the GPU comes through these pins on one and the other side, and depending on the card, it's either 6 or 2/6 connectors or 8 pin connectors, but basically that's the external power, because there's limitation how much power the board can deliver, right? But basically this is data and this is power and a few other things. There are two sides, and let me grab a pinout. So we have side A and side B. This is side B, this is side A. Okay, so let's start with A. And now let's put the maybe multimeter over here so we both can see. And now going from the right, first 3 pins, let's see, side A. First pin is hot plug presence detect. Alright, that pin, so we don't care about that one. I'm gonna put black probe on the ground. And pin number 2 and 3, that's 12 volts, so we expect about 0.6 voltage drop. And we have 0.66 on 1 and 2. And then 3.3 volts is this one. We expect about 0.5, a little less, 0.45 and 0.45. So 12 volts and 3.3 coming through here are good. Now on the other side, side B, first 3 pins are 12 volts, then ground, sorry, then SM bus clock and data, then ground 3.3, some JTAG, 3.3 auxiliary, and wake. So first let's check the 12 volts, same thing, black probe on the ground, and we expect 0.6, 0.6, 0.6, well these are all connected. And 3.3 is auxiliary, is second from the last, but auxiliary is not always present. This one's not present, and it looks like the pin is not connected. So pin number 8, so that's 4 from the right, 1, 2, 3, 4, and 0.45. Okay, so, but this is very uncommon for the shorts to be, well, very uncommon. It's either a short will tell you this, and open line will tell you this. Both are bad, so we don't want to see either open line or a short, right? Now, the most probable cause is the actual big power pins, and that's where most of the power comes through. The pins look good, and let's do the ground, and 1 volt, that's ground, 1, that's ground, 1, 1, and 1, okay, so that is a little bit concerning because we don't see the shorts or open lines, and that is a bad news because shorts and open lines are kind of easy to fix. So now let's see if we have some shorts on the data lines, because that could be another source of shorts. There's technically not a lot of current flowing through these, right? So normally there's not a lot of strain on the not a lot of work that they need to actually perform those elements on the logic side of it. It's rather all that power stuff that comes in through here and through here that breaks, but it's possible. It's an old card, so anything is possible here. Come on, card, get in there. There you go. Okay, And you probably can see. Let's do this. Now you'll be able to see perfectly. Okay. All LEDs are lighting up. So if there's a short or open line, the LED will not light up. All of them, all 16 or the, what is it, 32 of them are lighting up. So there are no shorts or open lines on the data pins. That's not good. In that case, let's do this. Let's get some PSU, maybe this one. One good thing about fixing PSUs, you always have abundance of PSUs for testing. And let's see if it will produce any image. This board obviously, I know it's only partially working. Not to say that it's pretty much not working, but yeah, it's working partially just fine. Let's maybe move the camera a little bit over here so I have more room to maneuver. Now let's connect the power, the P4 12 volts. Oh, come on, was it not P4? Yeah, it is. There you go. I'm just clumsy today, I guess. And cable for the monitor. Let's hook it up maybe to the bottom one. I don't remember which one's primary, which one's not. So I'll just do this. And we need a power for the card, although it will produce image. Normally when you connect it without this, it should still display an image saying that the power is not connected. Make sure the connection is good over here, although this is not very powerful card. It's not bad, but sometimes these can literally just burn, just melt, completely melt, because there's just that much current going through there. And now this is light bulb, and this is regular, like so. And now let's see, is it gonna start? Okay, this is starting. This is, oops, hang on, because I got no heat sink. And it's too big. The card is too big. The heat sink's not gonna fit. Let's just take off the chipset heatsink and put it on CPU, and let's just put some weight on it, because I just want to see the image. And even if this CPU burns, I really don't care that much. I mean, I'd prefer it wouldn't burn, but if it does, I'm not gonna cry about it. And let's see what's gonna happen. No image yet. Oh, the screen went black. We have blinking cursor. Crap. Okay, so the the card is actually working. Yeah. So that is quite a surprise, because it didn't work in the other machine. No shorts. See, normally now I would just start it on this rig, because this was supposed to be my GPU testing rig, boot into Linux, and run the memory test. But this is not a memory issue, because the computer just died and wouldn't start until I replaced the card. So this must have been some power issue. And I just realized something. The GPU that I have right now replaced in my rig is the one that doesn't require external power, because it's just like really old, like regular use GPU. You're not gonna game on it, and definitely not gonna do mining on it, but it's decent. So it requires a lot less power to operate, and all the power comes from here. This one takes power, mainly power from here. So if this card is actually working, and it looks like it does, that means that it's actually not the card that broke. It's the PSU that failed. So as long as the card was connected, it was trying to draw more current, and probably there was a voltage drop, and the red blinking light on the board could mean that the PG didn't go up within 500 milliseconds. If that be the case, that's probably need to recap the PSU. Did not expect that. I thought this was a GPU repair. But I guess we're just gonna leave it as a GPU diagnostic, to like short finding or open line finding. So that's like a very basic diagnosis or diagnostic process. It's not gonna tell you much, but I say this GPU is okay. I say this is working, it just didn't get enough power. That's why it couldn't start. So now I need to dig out the PSU from my rig and recap that one. I guess that's going to be another video then. Well, we didn't fix it, but we did confirm that it's not broken. Unless you have some ideas that maybe I'm doing something wrong here. Maybe I missed something. Definitely drop a comment about that. Alright guys, thank you very much for watching, and I shall see you in the next one.